Okay, so here we have another system of equations, and the instructions are, if possible, solve the system. So it doesn't tell us how to solve it. We can use graphing, substitution, or elimination to do it. Usually, most people find the elimination method to be the easiest of the different strategies, and so we're going to do that. But before we can start, in this problem we have decimals. Previous problems we had fractions we need to get rid of before we can start to add the equations together. So in this problem, all we have to do is multiply each of the two equations by 10. When we do that, we're going to be able to get rid of all of the decimals. And in turn, what happens is that the decimal point is just going to be moved one place to the right in each term. So the first equation, 5x minus 2y equals 13. Second equation, we're moving the 1.0 decimal place to the right. It's going to become negative 10. X plus 4y equals negative 26. So before we can add these two together, to eliminate one of the variables, you can see we can either work with the 5x and negative 10x, or the negative 2y and positive 4y. I think in either case, we want to multiply the first equation by 2. So we'll get 10x minus 4y equals 26. Second equation stays as is. Negative 10x plus 4y equals negative 26. And let's see what happens here. Each of the three columns are going to zero out. So we end up with 0 is equal to 0. When you solve an equation and it ends up with a number equals the number, the same number, then you know that that's true for all cases. So 0 is always equal to 0. And since that's the case, we know that we have two equations that are essentially the same. So there are infinite solutions. That tells us that we have two lines that are basically lying on top of each other, or two lines that are exactly the same, and there are an infinite number of solutions to this. Okay, we'll stop this video here.